Now it is now to define the linear speed of any point on a rotating object. For example, as I said, when this object is rotating, every point on this object rotates with the same angular quantity, with the same angular displacement, with the same angular speed, with the same angular acceleration, because it is a rigid object. Every point connected to one another. However, the point which is closer travels a shorter distance. Look at here. When this point travels that distance, but the farthest point travels longest. Look at here now. So as you see, arc length for this one is longer. Arc length for inner point is shorter. A little shorter arc length, longer arc length. This point must travel this distance in the same time. So for that reason, you should run this distance faster to travel the same time than this one. For that reason, the point when they approach to the center of the rotation, which is the axis of rotation, the speed, linear speed of this point is decreasing, but the point outside, right, that is moving faster in linear speed than that one. This linear speed we are going to define as the tangential speed. Why? Because this point, any point on this circle is moving tangent to the circle. Now look at this pan. This pan is a line tangent to this circle or disk. So while the disk is rotating, this pen is also rotating, but its speed is always tangent to the circle. That is why we say this is the tangential speed. And the speed of a point, linear speed of a point on a rotating object is known as, or we are going to say this from now on, the tangential speed, because this speed or velocity vector is always tangent to the circle drawn by that point. So now we are now going to define them, tangential speed and acceleration. If two objects are at equal distances from the axis of rotation, they have equal instantaneous linear speed called tangential speed. Now it's a good example. In this what is this called? Right here, there is a horse and there is a lion. Because their distance are the same, so they travel with the same speed, because it is merry-go-round, I think this is called. No, it's not. So it is rotating with the same linear speed, tangential speed. The distance between them never changes. So can the lion catch the horse? No, they cannot. Why? Because their tangential speeds are equal. Why? Because they are at the same distance from the center axis of rotation. But if two objects are at different distances from the axis of rotation, they have different tangential speed. So which horse moves faster in linear speed? Because this is in outer, this is moving faster. So the horse on the outside must travel a greater distance, greater arc length delta s, than the horse inside. So the horse on the outside must travel a greater distance delta s than the horse inside. Thus, the object that is farther from the axis of rigid object, rotating body, must travel a higher tangential speed around the circular path. I can show it like this. So it is a rigid object. This point, one inner point travels a shorter arc length, but outer point travels a longer arc length. For that, as its tangential speed must be greater. So we know the relation between the arc length and angular displacement. Yes, we know. Arc length is equal to radius times angular displacement. If we divide these two quantities by delta t, both sides of the equation, so delta s over delta t is known as the tangential speed. Delta theta over delta t is known as the angular speed. This equation says us. So because every point has the same angular speed, because it's a regional object, its angular quantities are the same for every point. According to the radius, tangential speed changes. If radius in sample problem 1e, the radius of a CD in a computer is 0.06 meter. If a microbe riding on the disk's rim, what does this rim mean? It's a CD. So it is the center, Right here, rim. This point is known as rim. So the microbe is riding on the disk, on the seated at the rim. So radius of the circle will be, in this case, the radius of the disk. So radius of the disk is the radius of the circle drawn by the microbe, 0.06 meter. If the microbe is riding on the disk rim, has a tangential split, yes, at that point, the microbe has a tangential split, which is equal to 1.88 meter per second. So tangential speed of the microbe is 1.88 meter per second. What is the disk's angular speed? So this disk is rotating with an angular speed omega. What is the angular speed of the disk? So tangential speed is equal to radius of the circle multiplied by angular speed. So angular speed is equal to, in this case, divided by r divided by r. So angular speed is equal to tangential speed divided by r. Tangential speed is 1.88, r is 0.06, divided by this number, 31.3 radian per second. So practice problem 1e is just by using the equation we can calculate the tangential speed. Tangential speed is equal to radius of the circle multiplied by angular speed of the object. So radius is given here 0.03. Angular speed is given as 121.5 radian per second. Multiply them and get the result as some number meter per second. So next one is angular speed must be calculated. Tangential speed is given. So divide by r, divide by r. So angular speed is equal to tangential speed divided by radius. So tangential speed is 0.75 here. Radius is 0.05. So this is equal to almost 15 radian per second. So next one is tangential speed is asked. Radius is given. Angular speed is given, but revolution per second. So don't forget, you have to convert revolution to radian. How? By multiplying 6.28. So this is the angular speed in radian per second. So you will multiply and find the answer. In the next one, radius is asked. Tangential speed is equal to radius times angular speed. Because you are going to calculate the radius, simplify angular speed. Radius is equal to tangential speed divided by omega. Tangential speed is given as 2 pi. Angular speed is given 1.5 pi. Simplify pi. It is equal to 2 over 1.5 meter as the answer. Sectional question. Find the tangential speed of a ball that is swung at a constant speed of 5 radian per second square on a rope that is 5 meter long. So there is a 5 meter long rope. On this rope, at the end of this rope, swings a ball. Because this ball is making a circle, so length of the rope is the radius of the circle, which is 5 meter. So right here we will calculate the tangential speed if the angular speed of the rotation is or revolution is 5 radian per second. So omega is 5 radian per second. Radius of the circle is 5 meter. Calculate the tangential speed of the ball. So because tangential speed is equal to r times angular speed, r is 5, angular speed is 5, 5 times 5, 25 meter per second is the tangential speed of the ball. Now, because the tangential speed also can increase for a rotating object. Remember, if an object speeds up or slows down, both speed can change, angular speed and tangential speed. From angular speed change, we calculate angular acceleration. From the tangential speed change of a point, any point, we calculate the tangential acceleration. So it is for a speeding up object or slowing down object, okay? Or rigid object. So if the pirate ship is an example, speeds up, so it's in this direction, it's speeding up or slowing down. So it has an angular acceleration. We defined this before. Linear acceleration related to this angular acceleration is tangent to the circular path, and it's called the tangential acceleration. Yes, the point here also has a tangential acceleration. So we know that tangential speed is equal to radius times angular speed. We defined this before. But if there's a change in angular speed, there must be a change in the tangential speed. If we divide this change by time, we calculate the acceleration. Tangential speed change divided by time is tangential acceleration. Angular speed change divided by time is angular acceleration. So then you can get a relation between the tangential acceleration and angular acceleration by r times alpha. So tangential acceleration of a point on an rigid object is radius of that point, radius of the circle drawn by that point multiplied by the angular acceleration of the object. So let's do an example. A spinning ride at a carnival has an angular acceleration alpha. How far from the center is a rider? How far from the center represents the r, because the point from the distance to the point, from point to the center, is known as the radius. Is a rider who has a tangential acceleration with a tangential acceleration 3.3 meters per second square. So tangential acceleration is 3.3 meters per second square. Angular acceleration is 0.5 radian per second square. Calculate the radius. So this is a equation. To calculate the radius, divide by alpha. So then r is equal to a tangential acceleration divided by angular acceleration, 3.3 divided by 0.5, which is 6.6. A child on a merry-go-round undergoes 1.5 meters per second square linear acceleration. So this is the linear acceleration a t. Now, linear acceleration and tangential acceleration are the same. Linear, tangential, same quantity. And linear, when it says, you will understand it is tangential. If merry-go-round's angular acceleration alpha is 1 radian per second, how far is the child from the x of rotation? How far from the x of rotation? How far from the center refers radius? Calculate the radius. So a tangential is 1.5 meter per second squared. Angular acceleration is 1 radian per second squared. Calculate r, radius of the circle. Tangential is equal to r times alpha, divide by alpha, simplify. R is equal to tangential acceleration divided by angular acceleration, 1.5 divided by 1, which is equal to 1.5 meters. So this is the solution of the practice problem. Next one is, what is the tire's angular acceleration if the tangential acceleration at a radius is 0.15 meter, at the radius of 0.15 meter is 9.4 times 10 to the power of negative 2 meters per second square. Look at here, meter per second square, linear acceleration, tangential acceleration, linear tangential. What is the tire's angular acceleration? Alpha. If the tangential acceleration is 9.4 times 10 to the power of negative 2 meters per second at a radius r, 0.15 meter. R is equal to 0.15 meter. Tangential acceleration is 9.4 times 10 to the power of negative 2 meters per second squared. Even look at the unit, you can understand it is meters per second squared. So calculate the angular acceleration. We know that tangential acceleration is equal to r times alpha, because we will calculate the angular acceleration simplified by r. So alpha is equal to a tangential divided by r. Tangential acceleration 9.4 times 10 to the power of negative 2, not 12, negative 2 divided by r. R is 0.15. When we divide this number, you will get the result as 0.63 radian per second squared. It is the angular acceleration. If an object has a tangential acceleration of 10 meters per second squared, the angular speed will do which of the following. Because there's an acceleration, speed is changing, certainly. If the tangential acceleration is given as positive, speed is increasing. If it is negative, speed is decreasing. If tangential acceleration is 0, stays the same. Next title is the centripetal acceleration. Now, centripetal acceleration is completely different than the tangential acceleration. It is completely different than the angular acceleration, because angular acceleration and tangential acceleration is because of the speeding up or slowing down of a rotating object. But centripetal acceleration is because of the change in direction of the motion of the object. While an object is moving on a circle, because the velocity is a vector quantity, its direction of the motion is continuously changing, then the object will have a centripetal acceleration. Centripetal, center seeking acceleration. Centripetal means center seeking acceleration. Yani looking for center or facing towards the center. This is the meaning of centripetal acceleration. So a car is moving in a circular path. As you see, a car is moving in a circular path with a constant tangential speed of 30 km per hour. Because its tangential speed is constant, this car has no tangential acceleration, no angular acceleration, because its speed is constant. However, because the velocity is a vector quantity, so direction of the motion, direction of the velocity vector is changing. So velocity is a vector. There are two ways to change the velocity on an accelerated car. One of them is by changing the magnitude of the velocity. This can be provided by speeding up or slowing down. So by speeding up and slowing down, we can change the magnitude of the velocity. But by changing the direction of the motion, we change the direction of the velocity. So also we can accelerate the object. So centripetal acceleration is related to this condition. The tangential acceleration and angular acceleration is related to the first condition by changing the magnitude of the velocity, which is speed. And the second one is by changing the direction of the velocity. So this is because of the change in the direction of the velocity, we got centripetal acceleration. So for a car moving in a circular path, with constant speed, even its constant speed is constant, the acceleration is due to the change in direction of the motion, So the acceleration of this nature is called centripetal acceleration. And because acceleration is a vector quantity, so this acceleration will always point to the center of the circle. Okay, so this is the Earth, this is the Moon, a satellite revolving around the Earth. So it has a constant tangential speed, it will have a centripetal acceleration always pointing the center. Why? Because direction of the velocity, direction of the motion continuously changing, and this results as centripetal acceleration. Okay, in fact, calculating the magnitude of the centripetal acceleration is not so difficult. An object is seen first at point A. So this is the first position of the object while it's moving in a circle with a tangential speed of V initial. So this is the initial tangential speed. So at time is equal to T initial. Then at point B, so of course object is moving and finally it comes to the point B. So it has another velocity here, velocity final, at time is equal to T final. The change in velocity can be calculated by V final minus V initial. Because the velocity is a vector quantity, we shouldn't forget to put the arrow sign. So the change in the velocity can be determined graphically as shown by the vector triangle. So what is change in velocity? V final minus V initial. What does it mean? Locate V final at negative of this to the head of the final velocity, which is V initial, negative V initial. So this is the change in velocity. This is delta V. This is delta V. So delta V will be pointing towards the center. Yes, this change in the velocity, delta V, always points towards the center of the circle. The acceleration will also be directed towards the center because acceleration will be in the same direction of the change in velocity. So direction of the change in velocity and direction of the acceleration will be the same. So the acceleration will also be directed towards the center of the circle because it is in the same direction of delta V, yani change in velocity. How can we calculate the magnitude of the velocity, the magnitude of the centripetal acceleration? The magnitude of the centripetal acceleration is given by the following equation. Centripetal acceleration is equal to V tangential speed squared divided by R, or R times omega squared. Even the tangential speed is constant, as you see, there is a centripetal acceleration. But this centripetal acceleration is not because of the change in tangential speed, because of the change in direction of tangential speed. Okay, sample problem. A test car moves at a constant speed around a circular track. If the car is 48.2 meters from the track center, what is this? Center distance to the center of a circle. It is radius. It is r, and has a centripetal acceleration. AC. What is its tangential speed? Calculate VT. So radius is 48.2. Centripetal acceleration is 8.05 meters per second squared. Calculate the tangential speed. Equation for calculating the centripetal acceleration is Vt squared over r. So cross multiply them, and you can, after cross multiplication, Vt squared is equal to r times AC. Can then square root of the equation. So Vt is equal to square root of r times AC. R is how much? 48.2. What is centripetal acceleration? 8.05. So when you multiply and then square it, result will be 19.7 meters per second. So this test car is moving with a constant speed of 19.7 meters per second on a circle and experience an acceleration, centripetal acceleration, which is equal to 8.05 meters per second squared. Practice problem 1. A race car moves along a circular track. Again, it's a circular track. At an angular speed of 0.512 radian per second. So this is also constant angular speed. So omega is 0.512 radian per second. If the car's centripetal acceleration is 15.4 meters per second square, centripetal acceleration, AC, centripetal acceleration, AC. So AC is equal to 15.4 meters per second squared. So what is the distance between the car and the car center? Calculate the radius of the circle. So AC is equal to R times omega squared. So R is equal to AC divided by omega squared. AC is how much? 15.4. Omega is how much? 0.512. Square of that number. Answer will be 58.7 meters for this question. Now question number 2. A piece of clay sits 0.2 meters from the center of the potter's wheel. So potter's wheel is a kind of wheel. It is the center. A piece of clay sits somewhere here, which is 0.2 meters from the center, which is the radius of the circle, 0.2, because this piece of clay will make a circle. So radius of that circle will be 0.2 meter. If the potter spins the wheel at the angular speed of 20.5 radian per second, so then this will start to rotate with angular speed, which is equal to 20.5 radian per second. So omega is equal to 20.5 radian per second. What is the magnitude of the centripetal acceleration? So AC is the question. So how to calculate AC? R times omega squared. What is R? 0.2. What is omega? 20.5. Square of 25. Answer will be 84 meters per second squared. Next question is the section review question. If a spinning amusement park ride has an angular speed of 1.2 meters radian per second, omega, angular speed. So 1.2 radian per second. What is the centripetal acceleration of the person? Standing 12 meters from the center. 12 meters from the center of the right means R. So this is R. So R is 12 meters. And calculate what is the centripetal acceleration? AC is the question. AC can be calculated by R omega squared. R is known, omega is known. So R is 12, omega is 1.2, square root of 1.2. Answer becomes 17.3 meters per second squared. Okay, of course, if there is an acceleration which is called centripetal acceleration, there must be a force which causes this acceleration. It is so simple because according to second law of motion, if there is an acceleration centripetal, m times a gives the force which causes that acceleration. So this force will be in the same direction of centripetal acceleration, and this force is the force which causes the object to move on the circle. So consider a ball of mass m tied to a string of length r, radius, because length of string is this radius of the circle, and being whirled in a horizontal circular path. The ball experiences the centripetal acceleration we know, directed towards the center. Centripetal acceleration is always towards the center. So, in fact, if you don't connect this ball with a string, this tendency of the motion of this ball is to move on a circular path. This is the inertia, it's called. The inertia of the ball tends to maintain the ball's motion in a straight line path. So inertia wants this ball to move on the straight path. But this string counteracts this tendency, stops this tendency by exerting a force on the ball. So pulling the ball towards the center and pulling the ball and causes the ball to leave from this path, straight path, and move on this circular path. What causes this? A force. So this force also directed along the string towards the center of the circle. So this force can be calculated according to second law of motion by F is equal to m times AC. So the magnitude of this force can be found by applying second law of motion, which is Fc is equal to m times AC. It's Newton's second law. The force, that means circular motion, is the net force acting on the object and called the centripetal force. That force which keeps the object on the circle, which provides the circular motion. Otherwise, if no centripetal force, object will follow the straight path. So the force causes or stops or cuts this tendency and causes the object to move on a circular path. What force is this? It is the centripetal force. How can we calculate it? By second law of motion, m times AC. So m AC can be written by v squared over r, tangential speed squared over r, or r times omega squared. So we can write also centripetal force by these two equations, m vt squared over r or m r omega squared. As I said, centripetal force is a general force, but every kind of the force can be a centripetal force if it causes object to move on a circle. Centripetal force is no different from any other two forces we have studied. For example, you move this ball or the hammer, this hammer on a circular path. So how? By applying a tension. Tension in the string causes this object to move on the circular path. Right here is the tension, is the centripetal force. A race car is turning round, and if there is no friction, it is not possible for this car to turn around. For that reason, force of friction is the centripetal force here, which causes the circular motion of this car. Earth is revolving around the sun. If one force is not exist, the Earth will not follow the circular path. That force is the gravitational force. So sun attracts the Earth towards itself, and this force of gravitation, causes Earth to move on the circle. Right here, force of gravitation is the centripetal force. So there are of course other types of forces, but in general we can say that the force which causes an object to move on a circle is a kind of centripetal force. If one force acting on the object, that force is the centripetal force. If more than one force acts on object while the object is moving on a circle, resultant of these two or more forces will be the centripetal force. Question. A pilot is flying a small plane at 30 meters per second. So this in a circular path with a radius of 10 meters. So it's a circular path whose radius is equal to 100 meters, sorry. So moving with a tangential speed Vt, how much is this speed? 30 meters per second. So if a force of 635 newtons is needed to maintain this pilot circular motion, so pilot is also moving on a circle with the plane, but we're not talking about the plane here. We're talking about the pilot. It says that pilot needs a centripetal force of 635 Newton to move on this circular path. So what is the pilot's mass? So equation for centripetal force is what? Fc is equal to mvt squared over r. The Fc is known, Vt is known, R is known, what is unknown? M. How can we calculate M? Simply cross multiply M. M is equal to R times Fc divided by Vt squared. So R is 100, Fc is 635, Vt is 30, square root of 30, which is, answer becomes 70.6 kilogram. Another question. A girl sits in a tire that is attached to overhanging tree climb by a rope of 2 mm in length. So there is a rope. A girl is sitting on a tire, which is at a distance of 2.1 meter from the tree. So of course this girl will start to swing in this on a circle. Or not complete circle, but a kind of circular path. The girl's father pushes her with a tangential speed of 2.5 meters per second. So this girl is pushed with a tangential speed. How much? Vt is equal to 2.5 meters per second. If the magnitude of the force that maintains circular motion is 88 Newton, so a force, which is centripetal force, causes the girl to move on the circle. That centripetal force is given as 88 Newton. Fc is equal to 88 Newton. What is girl's mass? Calculate the girl's mass. And we know the radius of the circle is the length of this rope, which is 2.1 meter. So Fc is equal to mvt squared over r. So how can we calculate this? M is equal to rfc over vt squared. R is how much? 2.1. Fc 88. Vt 2.5. Square of 2.5. So answer becomes in this case 29.6 kilogram. So next question. A 905 kilogram car travels. Yes, mass of the car is given as 905 kilogram. Travels around a 3.35 kilometer circular track. It's a circular track. The car is traveling around this circular track. So this 3.35 kilogram circular track is the length of the circular track. Generally, students take this as a radius. As soon as you see a length, it doesn't mean that it's the radius. So it is the length of the circular track. Yani circumference. Circumference, yani arc length. 2 pi r is given as 3.25 kilometer. Yani 3,250 meter is arc length or circumference. 2 pi 6.28 multiplied by r. First you should calculate r. So right after that you will calculate the rest. If the magnitude of the force that maintaining car circular motion is 2,140 Newton. So centripetal force is 2,140 Newton. What is the car's tangential speed? Vt is the question. So how can we calculate Vt? Because Fc, centripetal force, is equal to m Vt squared over r. Cross multiply them. Vt squared is equal to r times Fc over m. Then square root the equation. You can calculate what Vt is. Vt is equal to R, must be calculated right there. So I don't have calculated right now. You can calculate it. R multiplied by Fc is given 2140. So M is given, which is 905. Then use your calculator. You can get the answer as 35 meter per second. So in general, we can say that any kind of force which causes an object to move on the circle can be assumed as a centripetal force. And we don't say that centripetal force is not like a friction force. It is friction force itself if it causes a car to turn around. Centripetal force is not a force which causes Earth to move. Gravitational force is the force which causes Earth to move, and it is the centripetal force. Or electrons are revolving around the nucleus. So electrostatic force between the nucleus and the electron is the centripetal force causes electron to move on the circle. So any force, any kind of force, type of force, which causes an object to move on a circle is called centripetal force. It could be only a single force or more than one forces. If more than one force is acting on the object, you should calculate the resultant of them. Then resultant force will be the centripetal force acting on the object. Okay, if centripetal force vanishes, what's going to happen? If this centripetal force vanishes, the object does not continue to move in circular path. Remember, normal tendency of an object, is to move on a straight line. It is called inertia. But by applying the centripetal force, we cut this tendency. We cause object to move on the circle. However, if the centripetal force is vanished, for example, if the string breaks, object will continue following the straight path. So, if the string breaks when the ball is at this position, the object centripetal force will vanish and the ball will move vertically upward on a straight path. The motion of the ball will be that of a free-falling object. It will move up and then come back down again. So, if the string breaks at this position, so because object is moving at this position to right, so it will follow a straight path. However, because of the gravitation G, so it will follow a projectile. The ball will fly off horizontally in a direction tangent to the path, then move in a parabolic path of a projectile. Okay, as a driver, generally you feel this force when you are driving. As the driver makes a sharp left turn, the passenger slides to the right and hits the door. Maybe you experience this while you are driving your car. What causes the passenger to move towards the door? This is the question. So before the car enters the turn, passengers is moving in a straight line path. Not only passenger, the car and the passenger, all are moving on a straight line path. As the cars start to turn a curved path, passenger, because of its inertia, tends to follow the straight path, move along the original straight line path. If a sufficient centripetal force acts on the passenger, yes, how can you make the passenger to move in a circle? By applying a centripetal force. If centripetal force is sufficient, if enough, in this case, passenger will move on a circular curved path. But if centripetal force is not enough, passenger will move on a straight path, but the car is moving on a curved path. For that reason, in fact, because of the change direction of the motion of the car, you are going to hit the door of the car. So the origin of the centripetal force is the force of friction between the passenger and the seat. Yes, between the passenger and the seat, there is the centripetal force. Which is the centripetal force, is the friction force. If this friction force is not sufficient, if it is not enough, the passenger slides across the seat as car turns. Eventually, the passenger encounters the door, which provides a large enough centripetal force to enable the passenger to follow the same curved path as the car. So you are going to slide and hit the wall. When you hit the wall will apply another force towards the center, which is normal force, and causes your body to move on the circular path. Okay, conceptual challenge. Pizza makers traditionally form the crust by throwing the dough up in air and spinning it. Why does it make pizza crust bigger? So if you spin pizza faster, centripetal force is equal to mr omega square. If you spin it faster, so centripetal force will be greater. So, but if the centripetal force which keeps this pizza crust is not enough, in this case, pizza crust will start expanding because of the tendency of an object to move on a circular path. Remember, inertia. So doves normally wants to move on a straight path, but the force, which is the adhesive force between the pizza, between doves, between the pizza, so keeps the doves to move on a circle. But if this force is not enough, of course, these doves will start to follow a straight path, and it will make the pizza crust larger in area. So what causes the swings to move away from the center of the right when the center columns begin to turn? Normally, because it's moving on a circular path, we need a centripetal force. So what causes the centripetal force in this swing? It is the tension. Tension causes the centripetal force. One component of the tension is the centripetal force, which causes the swing to move on the circle. But if swing starts to move faster and faster, centripetal force must increase, mr omega squared. Because omega increases, centripetal force must also increase. How can the centripetal force increase? If this angle decreases, the horizontal component of the tension increases. That's why it's like this. So initially, if the swing is like that, so only the centripetal force is this. But when the angle increases, length also magnitude of the centripetal force also increases. For that reason, when it starts to spin faster, so tension force, which causes centripetal force, must also increase. Only it can increase when this angle becomes smaller and smaller. That's why the swing moves away from the center to provide enough centripetal force. So a roller coaster moves through a vertical loop at a constant speed and suspends its passenger upside down. In what direction is the force that causes the coaster and its passenger to move in the circle? What provides this force? At this position, there are two forces acting on the coaster. One of them is the Fg gravitational force. Second one is the normal force between the track and the car, which is Fn, normal force. Because these two forces are pointing the center of the circle, these two forces could be the centripetal force. Fg, you cannot change Fg, but Fn can change. Depends on the speed. So, the gravitational force Fg must act on the roller coaster, which is one of the centripetal force, component of the centripetal force. Second one is the normal force Fn may act. I said may act on the roller coaster, depends on the speed. So, if the speed becomes smaller, Fn becomes smaller. If speed is enough small, Fn becomes 0. It's the minimum speed that car can safely move when Fn is equal to 0. So, identify the force that maintains circular motion of the following. A cyclist moving around a flat circular track. Cyclist is the man on the bicycle. Between the cyclist and the bicycle, there are forces. This force is always perpendicular to the surface. For that reason, between the body and the seat and the cyclist, one of the force Fn1. Between hands and the handle, Fn2. Between foot and the pedal, it is Fn3. So these are normal forces. So one component of these forces, horizontal component of these forces, are the centripetal forces, which causes the cyclist to move on the circular track. Next one. So bicycle moving around a flat circular track. In this case, there are three forces acting on the bicycle. One of them is static friction force between the ground and the tire. Second one is the normal force between the ground and the tire. Third one is the gravitational force acting on the bicycle. But as you see, just one single force points to the center of the circle. It is the friction force. Right here is the static friction force causes the bicycle to move around a flat circular track. Bobsled turning a corner on its track. While bobsled is turning a corner, so the forces acting on the bobsled will be downward forces Fg, a kind of static friction force which is Fs upward, and normal force between the track and the bobsled. As you see, just one single force points to the center of the circle. It is the normal force. Right here is the normal force, is the centripetal force, which causes the bobsled to move on a circular track. All right, so the last title in this chapter is Gravitational Force. So planets, planets move in a nearly circular orbits around the sun. And remember, we said that if an object is moving on a circle, there must be a force causing it to move on that circle. That force here is known as the gravitational force. So the sun attracts Earth or other planets with a force, gravitational force, cause it to move on the circular path. The astronomer Johannes Kepler proposed that all planets orbit the sun in elliptical paths. Elliptical, some are very close to circle, some are perfect ellipse. Isaac Newton was able to derive equation for an elliptic path suggested by Kepler. The force that keeps this planet around the sun is the gravitational force. Gravitational force is a field force. What is field force? As you see, two objects are not in contact, but they can attract one another. So this kind of force is called field forces. And these forces always exist between two masses. Gravitational force acts such that objects are always attracted to one another. So if the sun is attracting the earth, earth is also attracting the sun. These are action-reaction forces equal in magnitude, opposite in direction, acting on different objects. And we can calculate the gravitational force by this equation. If masses m1 and m2 are separated by a distance of r, the magnitude of the gravitational force is given by the following equation. F is equal to g, universal gravitational constant, m1, mass of the first object, m2, mass of the second object, divided by square of the distance between them. So g is known universal constant of gravitation. It is a number 6.67 times 10 to the power minus 11. And it will be given in the question. You shouldn't worry about this. So the law of universal gravitation is an example of inverse square law, because force changes what is as the inverse square of the separation. Because as the square of the radius increases, so force decreases by the square. For that reason, this law is known as inverse square law. Question number, sample problem. Find the distance between 0.3 kilogram billiard ball and 0.4 kilogram billiard ball if the magnitude of the gravitational force is 8.92 times 10 to the power minus 11 Newton. So mass 1 is given, mass 2 is given, F is given, R is known, R is a question. So G must be given, G is equal to 6.67 times 10 to the power of negative 11 Newton times meter square per kilogram square. This will be given in the question, you shouldn't worry about this. Fg is equal to G m1 m2 over R squared. Cross multiply them, you can get R as root of G m1 m2 over Fg. So after that, G m1 m2, don't forget, if it is given gram, you should convert it to kilogram, but in the question is given kilogram, no problem. Divided by Fg is 8.92 times 10 minus 11, answer becomes 0.3 meter. Okay, now this question, the previous question was about the two space objects, but gravitational force is not only exist on between space objects. For example, when you are standing on a scale, you measure a weight. So, which shows that the gravitational force also exists between you, your body, and the earth, like this here. So, Earth is pulling you towards the center. In fact, you are also pulling the Earth, but because your mass is smaller than Earth's mass, so your acceleration will be greater than Earth's acceleration. In fact, no force acts single alone. If there is an interaction between two objects, so one object applies an action force, the other object gives a reaction, always. And the forces are in pairs in the nature. But we are not dealing with the force acting on the Earth because we experience the gravitational force and we experience the gravitational acceleration. So while calculating gravitational force exerted by a spherical mass on a particle outside the sphere, consider the entire mass of the sphere were concentrated at the center. Because Earth is so large, everywhere there is mass, but we will assume that all the masses of the Earth is concentrated at this point. So, for example, the force on an object of mass m at the Earth's surface has the following magnitude. Now we can calculate this. Mass of the Earth is at the center. This is mass of the man, small m. So the force acting on the man is Fg, can be calculated by Newton's universal law of gravitation, G, mass of Earth times mass of man divided by distance between the man and the center of the Earth, which is the radius of the Earth, of course, Re. So this is one way to calculate the force acting on your body. But also, we can calculate the force by two ways. One of the is this. Second one is this, by using the second law of motion. Remember, F is equal to m times acceleration. What is the acceleration of acting on the man right here? It's the gravitational acceleration. So Fg also can be written as m times g. So these two are equal to each other. These two are equal to each other. Yani we define the gravitational force by two ways. One of them is by using Newton's law of universal gravitation. Second one is by using the second law of motion. Then we are going to make them equal. Mg is the gravitation force from the Newton's second law. Gme m divided by r square is the gravitational force from the universal law of gravitation. So then if we simplify m, we can get an equation for calculating the gravitational acceleration on the surface of the Earth. G, gravitational acceleration on the surface of the Earth, is equal to G, capital G, which is universal law of gravity, multiplied by mass of the Earth divided by radius of the Earth squared. As you see, gravitational acceleration of a planet depends on its mass and depends on the square of its radius. So no other thing can define or determine the gravitational acceleration of a planet. So if the mass of each ball is 0.8 kilogram, at what distance between the balls will the gravitational force between the balls have a magnitude of 8.92 times 10 to the power negative 11? So mass of m1 and m2 is given here. It is equal to 0.8 kilogram. So the force of gravitation is given as 8.92 times 10 to the power of negative 11 Newton. So what is the separation between these two masses? Equation is known. Fg is equal to G, m1, m2 over r squared. So then you could calculate r squared. R squared is equal to G m1 m2 divided by Fg. G is known, 6.67 times 10 to the power of negative 11. M1 and M2 are known, which is 0.8 times 0.8 squared. Divided by Fg is given as 8.92 times 10 to the power of negative 11. So when you do this calculation, you will get the answer R as 0.69 meter.